So again, those of you who just came in, and well, to everyone, happy Tuesday, right? Hope you had a great weekend. I know it's never long enough. It's never long enough. So let's see. Let's do this. So first, polynomial goes inside the house. 3x cubed plus 7x squared plus 2x plus 3. And outside the house is x plus 1. Alrighty. So again, we look at the beginning of this x, and we look at the beginning of this 3x squared. What do I need? What do I have to multiply by? What do I have to multiply x by to get 3x cubed? Well, I need a 3. And then I already have an x, so what do I need to multiply x by to get x to the third power? Well, I need 2 more x's, so x squared. And so now I multiply 3x squared times x is 3x cubed, just like I want. And then I multiply it to that 1. 3x squared times 1 is plus 3x squared. And then I subtract. Remember, I subtract the whole thing. So 3x cubed minus 3x cubed is gone, and that's what you always want. You always want that first one to be gone. And then I have 7x squared minus positive 3x squared, so that is 4x squared. And then I bring down the next term, plus 2x. And then so I ask myself, what do I have to multiply x by to get 4x squared? Well, I need a 4, so a positive 4, right, because it's positive 4. Then I have an x. What do I have to multiply x by to get x squared? An x, right? Just an x, because x times, oops, that's the eraser. An x times x is x squared. So now we look, 4x times x is 4x squared. And then 4x times 1 is, that's easy, 4x. Then I subtract that whole thing. And so 4x squared minus 4x squared, just like we want, it's gone. It's a 0. And then 2x minus 4x, positive 4x, will give me negative 2x. Then I bring down the 3, positive 3. And so I ask myself, what do I have to multiply x by to get negative 2x? Well, I already have an x. All I need is negative 2. Yeah. And so negative 2 times x is exactly what I want, negative 2x. And then negative 2 times this 1, easy, negative 2. And then I subtract. Negative 2x minus negative 2x, right? Minus a negative becomes positive. So negative 2x plus 2x is 0, just like we like. So that's gone. And then here we go. We have 3 minus a negative 2. Well, minus a negative means plus, so 3 plus 2 is 5. And there's nothing else to bring down. So this is my remainder. So some of you did this. Some of you put remainder 5. And I said, oh, how cute. Then I said, oh, how cute. Because, hold on, what's going on here? Getting a little lag. Am I getting a little laggy, guys? My computer's like freezing a little bit. It's fine. Okay. So my computer's getting really slow. What's going on? So what do we do with that remainder? Do we say remainder 5? And I said, oh, how cute, because that's what we did back in elementary school when we first started doing this. Way back then when we did long division. But no, we don't do that. We're fancy. So we're going to, this is a 5, right? So it's a positive 5 remainder. So I'm going to put plus, because it's a 5. Well, let's do the same color. Plus, now what did we do when we came back here and we had a remainder? Let's look at what did we do over here? We had a remainder. Let's look at our numbers. When you don't know how to do something, when you don't know how to do a difficult problem, look at the real simple ones and see what you did there, and then do the same thing with the difficult problem. So this is our easy problem. This is the one with numbers. And if you remember, we had a remainder of 7 here. All right, we had a remainder of 7, and we didn't put R7. We got that 7, and we made a fraction. We put 7 over what we were dividing by, 7 over 13. So this became 420 and 7/13 because I have 7 pieces out of 13 because I was dividing by 13. And that's exactly what we do. We make a fraction. And we put the remainder over what we're dividing by. Okay, just like we did back in elementary school. So let's go back to that problem. So my remainder is 5. So I'm going to put 5 over, what are we dividing by? X plus 1. X plus 1. And there is our answer. Ew, I don't like the way that looks, mister. You don't have to like the way it looks, but that is the answer. When we have a remainder, we just put it over what we were dividing by. Okay, I'll give you a minute to copy that down or ask any questions. But this should be the moment where you go, oh, that's what I did wrong. That's what you should be looking at. If you did it wrong, you should be looking and seeing where you got it wrong, right? Because if you take anything from this class, I've been telling my other classes, if you take anything, like if I see you in 20 years, if you did work on the paper, that's fine. Yeah, you should have done it on the paper because it's difficult to do it on Desmos. So check your work on your paper and look at this work and see where you did it wrong. But if I see you in 20 years and you go, oh my God, there's my high school algebra 2 teacher, Mr. Pacheco, how you doing? And then hopefully you remember at least one thing, right? And that being wrong is perfectly fine. It's actually preferred to be wrong because that's where learning happens, right? You can't just be wrong and stop. You got to be wrong and then go, oh, that's why I was wrong. That's what I did. Okay, now I get it. See, that's called learning. That's where your brain grows, right? So hopefully if you get one thing out of this class, it's wrong is good, right? Wrong is where learning happens. So if you got it wrong, just see where you messed up. And if you don't know where you messed up, let me know. Ask me. Hey, mister, I don't know where I messed up. Can you explain this part? Can you explain that, what you did over there? What does that mean? How come you did that? Okay, I'll give you a minute to copy this and ask me any questions. Oh, my head's in the way. There we go. No questions? No questions? Okay. Before I send you off to do classwork, I want to where is it? I want to not do a whole problem. But I want to show you something. So take a look, and then you can copy what you want to after. But what if I was dividing this? And we're not going to do the whole problem. I just want to do the setup so you can see something called a placeholder, right? Like when I write the number 1005, what does that mean? What does 1005 mean? What do you want me to say, mister? It means 1005. No, what does it mean? Anyone know what 1005 is? Like, it's what? Think about place value. What is it telling you? When you see 1005, nobody? When you see 1005,
Bueller.
right. The one, why don't I?
Bueller.
Okay, we got it. Why don't I do this? Why are these two different? Why are those two different? Right? This is 1,000 and, right? 1,005 ones. And then what do these zeros mean? Right? Zeros mean nothing, so why don't I just take them out and just write it like this? Exactly. We have places. And if there's none, we have no hundreds and we have no tens. Okay? So we have no 100s, we have no 10s, we have a 1,000 and 5 ones. So we put zeros in there so it doesn't look like this because this means 15. That means 110 and 5 ones. Okay, so we put something called placeholders, right? These zeros are placeholders. And the reason they're there is so we know it's not 15, it's 1,005, and we have no hundreds and no 10s, but it lets our brain know, oh, those zeros are placeholders. I don't have any hundreds, I don't have any 10s, but the 5 is in the ones place and the 1 is in the thousands place. It lets you know where your place is. Does everyone understand that? I know it's an easy, like, duh, it's elementary school. Yes, perfect. So what if I did this? What if I said, okay, we're not going to do the whole problem. We're just going to start 5x to the 5th minus 3x cubed plus 4x plus 7 divided by x plus 9. Okay, guys see that? What do you notice about the large polynomial? What do you notice? It goes in the house, yes. So I would put this in the house. So I would put 5x to the 5th. What do you expect to come next after 5x to the 5th? What kind of term do you expect to come next? This is 5x to the 5th power. Now I'm going to put this here, right? But that's x to the 3rd, isn't it? What would you expect to come after x to the 5th, an x to the 5th term? Right? What would you expect to come next? What should come next after an x, 5x to the 5th? An x to the 4th, right? Exactly. Do you see an x to the 4th here? I don't. But there is one there. So we're going to do this so we don't mess up. Plus 0 x to the 4th, because I don't have any x to the 4ths, but I'm going to put a placeholder in there. Then next, I have an x to the 3rd, so minus 3x to the 3rd. I do have one of those. What should come after next x to the 3rd? An x squared, right? But do you see an x squared in our polynomial here? Do you see an x squared? No, so I'm going to put no x squareds, but I'm going to put it there because I want a placeholder. And do I have an x to the 1st? Yes, I do. I have x to the 1st, so I can put that plus 4x. And do I have a constant? Yes, plus 7. So you see what I did there? And then I put x plus 9 out here. But do you see what I did there? This is my polynomial. It has 1, 2, 3. It has 4 terms. But if you look in here in the house, I have 1, 2, 3, 4, 5. I have 6 terms. And why did I do that? Because I want to represent every x power. Because when I'm dividing and I bring things down and I'm multiplying to the thing out here, I'm going to get an x to the 4th. What am I going to put it under if there's no x to the 4ths? I'm going to get an x squared. What am I going to put it under if there's no x squared represented here? It's exactly like this. I'm just putting placeholders in the places where nothing exists. Okay, I didn't have any hundreds, I didn't have any 10s, but I still need to put a 0 in there. Same thing here. I don't have an x to the 4th power here, but I need to represent it. I don't have an x squared in between those, but I need to represent it so everything is matching. Does that make sense? Does everyone understand what I did here? When you're dividing and there are terms missing, right? It's just counting down 5, 4, 3, 2, 1, constant, right? I just want to make sure every one of these exponents is represented. And if I don't have one in here, just you put 0 of that exponent, of that variable with that exponent. Does that make sense? Show me a thumbs up or say something in the chat because I'm looking and I'm hearing. Alrighty, I see 1 thumbs up. So only 1 person gets it? Okay, 2. Someone says yes. 3. Okay, there we go. There we go. Yeah, just let me know. You guys got to let me know. I'm looking out there. Do we have to do replacements? You don't have to. Well, only the problems that are missing stuff, right? Like this problem so far that we've been doing haven't been missing stuff. If we look here, 3rd, 2nd, 1st, constant. Nothing was missing. Right? 4th, 3rd, 2nd, 1st, constant. So nothing has been missing so far. 3, 2, 1, constant. So we've been very lucky. Everything has been represented, but you're gonna run into problems. 3, 2, 1. Where in this polynomial, one of the terms is not going to be there. Okay, so they've been there. We've been lucky, but sometimes they're not going to be there. So when they're not there, you put in your placeholder. Okay. No, it's not getting harder. You just got to put a placeholder here. And it's the steps are exactly the same. Just, I don't have an x to the fourth. Just make sure I put 0x to the fourth. If I don't have an x squared, just make sure I represent x squared. That's all. 5. Uh-oh, there's no 4. I mean, that's okay. 3. Uh-oh, there's no 2. That's okay. 1 constant. I'm good. Yeah, so it's not harder. This isn't more difficult. It's just making sure you put your placeholders. So yeah, you're good. So here's what I'd like you to do. It is 11:27. We have 18 minutes. I want us to get started on our classwork. What our classwork is we are going, let's see, let me see if I can get it here. Dropbox. I love Dropbox. There it is. It's a maze. Ooh, amazing. You're going to have an amazing classwork. Yeah? No? No? Nobody? Nobody? Hello? Okay. Open in. Let me just show you real quick how this works. And you can do your work. Okay, you're going to do your work on a piece of paper, and you're going to turn in that piece of paper on Schoology. On Schoology, there is an assignment for you to turn in your work for this classwork. That's where you're going to turn in your work. So do your work on paper. You don't have to do it on Desmos, but you're going to show me. I'm going to see your maze colored in and stuff on Desmos. It's kind of like if I handed this out in class, right? But it's going to be on Desmos. And then you'll do your shading and your arrows and stuff like where you started. So let me show you what this looks like. Okay, so it's just a maze. So you start here, right? And then you do this problem, right? You do the division, and then your answer is either going to be this or this, okay? And then whatever it is, you're going to color it in or highlight it in on Desmos. And so that, or you can draw an arrow or both. And then you go to this one, then you do this problem, and then you're either going to go this way or this way until you get to right here, the end. Okay, so let me open that up for you guys. And so I'll give you the rest of the period to do as much as you can, then we'll continue this tomorrow. So let me open.